All right, now I want to tell you about a very special kind of sequence. These are known as arithmetical sequences. And let me give you an example of an arithmetical sequence and see if you can guess what makes it so arithmetical. How about 3, then 8, then 13, then 18, then 23, and this pattern keeps going. What is the pattern? Well, it seems like actually I need to know the previous one, and if I know the previous one, how do I get the next one? It seems like every time I just add 5. So an arithmetical sequence is just a sequence where to get the next term, you just take the previous term and add some fixed number. In this case, we just add 5, right? 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18, and so on. Now, in fact, there's a really easy way of sort of expressing this. Think about it. If to get the next term, you just take the previous term and add this fixed number, then if that number were, let's say, well, in fact, let me write this down this way. If I take the n plus first term, that's just the n plus first term in the sequence, whatever n is, and I subtract off the previous term, what will this have to equal? Well, it'd have to equal 5. Because to get this term, I just take the previous term and add 5 to it. So even though I don't know what n is, no matter which pair I take, if I take their difference, this minus that, it's 5. This minus that is 5. This minus that is always 5. That's what makes a sequence an arithmetic sequence. The difference of consecutive terms is 5. And notice that's just the generic way of me saying take a term and the one that comes before it, because the subscripts are off by 1. Well, now if you think about it, how can I actually write down a formula that generates that sort of these sequences? Well, let's see. Suppose that I have an arithmetical sequence, and at each stage I add d. So let's take an arithmetical sequence, and each stage I add d. So I have something like the first one, and the next term I'll have a1 plus d. The next one I'll have is a1 plus, and I take this, a1 plus d, and add d again. So that's a1 plus 2d. Then I take this and add d to it. That would be a1 plus 3d. And then I would have a1, and I add d, I add a1 plus 4d, and so on. Well, this actually gives us a formula, because if this is the first term, and this is the second term, and this is the third term, and this is the fourth term, and so on, we can see that a formula to get the nth term will be just a1 plus, now what number do I have to multiply d by? Well, in the third, I multiply by 2. In the fourth, I multiply by 3. So in the nth, I multiply by n minus 1. And that actually gives me a formula that actually allows me to find the nth term in an arithmetical sequence. For example, let's suppose that we have an arithmetical sequence, and a1 equals 3, and that difference between the terms is 2. Then what's a6? Well, we can find a6 really easily now. All we've got to do is say, okay, what is a6? Well, a6, using this formula, would be a1, which is 3, plus, well, this is the sixth term, so I take 6 minus 1, which would be 5, times that difference, which is told to be 2. So this is just going to be 3 plus 10, which equals 13. So the sixth term in this particular arithmetical sequence, the sequence that starts 3, and then 5, and then 7, because all I'm doing here is starting with 3 and I keep adding 2, the sixth term will be 13. So you can find that really easily.